Right, we're starting. Manon. All right, angles of elevation and angles of depression. Okay, we've already gone through this. An angle of elevation, if you have two pencils, would be going up. That's an angle of elevation. An angle of depression is the opposite. It goes down. But remember how you always have one flat spot. Okay. Our first example. What is the angle of elevation required for the airplane to clear the building? Well, this picture is kind of small, so I'm going to draw it a little bit bigger. No, I'm just going to draw a triangle. So we have a triangle. We know this building is 60 feet tall, and this is 200 yards away. And we know we have an angle of x. No, not in this question. Okay. Well, first off, we need to figure out which function we're going to use. We have an opposite. We have an adjacent. Do we have anything labeled by the hypotenuse? And put a big old X. All right, guys, don't yell at the answer. Tangent of, I'm just going to write the entire equation, is opposite over adjacent. Tangent of x is equal to opposite 60 over adjacent 200. It would be wrong. I was about to say something about that. You caught me before I could say anything. I was going to actually say this is wrong. Why is this wrong? Someone other than Rob.
Because it's 200 yards, not 200 feet.
Exactly. So instead of multiplying this by 3, I'm actually going to divide this by 2 or by 3. So I'm going to do 60 divided by 3 is 20. There's 20 yards and 60 feet. So we have tangent of x is equal to 20 yards over 200 yards. I've asked that every single period, and you're the first. Rob's the first person to say, and before I could even ask, before I could even tell someone that there's something wrong with it. Good job. Most of the time, it takes 2 or 3 guesses before they get it. Okay. So we have to undo this tangent. If you guys remember from before, whenever you're looking for an angle, and only when you're looking for an angle, are we looking for an angle? Yes, we're looking for an angle of elevation. You use the inverse functions. So we're going to end up having x is equal to tangent inverted of 20 over 200. Take your calculator. Inverse tangent of 20 over 200. Second, we'll just say 5.7 degrees. You probably didn't press second tangent. Oops. I guess. Banana. Okay, we're moving on. On to the back. A kite is being flown at an angle of elevation of 52 degrees. Here's your angle of elevation of 52 degrees. The kite string is 25 feet. Is this the kite string on the ground?
No.
Is this the kite string going straight up?
No, it's not
the hypotenuse. 25 feet. It wants us to find the height, which happens to be already labeled for us with an x. So we have a hypotenuse, we have an opposite. Do we have anything labeled for this adjacent? No, so I'm going to put a big old X there. We don't care about that adjacent. What's opposite and hypotenuse? Look on the board. Sine of x is equal to opposite over hypotenuse. Start plugging in your numbers. Sine of our angle, which is 52, is equal to opposite x over hypotenuse 25. Since x is on top, you need to multiply 25 times sine of 52 is equal to x. Take our calculator. 25 times sine of 52. 19.1 degrees. Don't forget your units. Oh, no, not degrees. I'm crazy. Feet. Okay. A flagpole. Oh, do I see a picture here? Guess what I'm going to be drawing? Okay. I first drew a triangle. Now I'm going to read the question. A flagpole is 18 feet tall. Do you think this represents a flagpole on the ground? Do you think that represents it? This is where our flagpole is. It's 18 feet. I'm going to draw a little flag there. And cast a shadow 12 feet long. Now seriously, a lot of people think this is the shadow. Have you ever seen a shadow in the middle of the air? No. Shadows are always on the ground. This line represents the ground, so this has to be 12 feet. It wants us to find the angle of elevation. Guys, I'm telling you right now, an angle of elevation is always on the bottom of a triangle. Every single time it's going to be on the bottom. Can it possibly be this? No. So it has to be this. This is the only one on the bottom. Opposite is 18, adjacent is 12. Nothing for hypotenuse. So opposite adjacent is tangent. Tangent x is equal to opposite over adjacent. Tangent x is equal to opposite 18 over 12. Nope, not inverse. Oh, sorry, you're right. Inverse. X is equal to inverse tangent. I'm sorry? Whenever you try to find angle, use the inverse. Inverse tangent of 56.3. And what's the units for this? Degrees, because it's an angle. Yeah. Okay. Okay. Now, a big thing about angles of depression and angles of elevation. Angles of depression and angles of elevation are always equal to the same thing. What does that really mean? That means they're the exact same angle. Okay? So if your angle of elevation is 27, your angle of depression is 27. So a lot of times on these tests, they're going to try to trick you and say the angle of depression is this. Well, you really know that's the angle of elevation. The angle of depression isn't nearly as useful as the angle of elevation, even though they're the same thing. So let me show you what I'm talking about. If you had two lines and this, here's our triangle. The angle of elevation is always the one that's on the bottom. So this is going to be your angle of elevation. Here's the tricky part. This is not the angle of depression. This one is, right here. Your angle of depression is outside of the triangle. Do you see? Do you see how, yes, do you see how we have this shaded in triangle here? It's going to be this angle outside of it. It is going down. It's going down from here. So it's this angle here, specifically. And the angle of elevation is this angle here, specifically. Okay? So if I were to redraw it with just the angle of depression, that would be the angle of depression right there. This is the side of the triangle. The elevation would be this one here. Yeah, elevations are inside, depressions are outside. Mm-hmm. Until you realize that this is actually two triangles, right? That's really just two triangles, and these are the same triangle, and that's why your elevation is the same as your angle of depression. Oh, I was just showing someone what it looks like without it being a triangle. All right, let's do an example. A building is 50 feet tall. A car is 200 feet away from the building. What is the angle of depression? We need to find this. But this is what makes it easy. If we could find what the angle of elevation is, which is right here, we know it's the same as the angle of depression, right? These two are the same. So we can use trigonometry to find this angle, which happens to be the exact same as one we're looking for. Opposite is 50, adjacent is 200. So we have tangent of x is equal to opposite over adjacent. Tangent of our unknown theta is equal to opposite 50 over adjacent 200. Inverse function, your angle theta is equal to inverse tangent of 50 over 200. Let's take our calculator. Inverse tangent of 50 over 200. Yeah, we'll just call it 14. 14 what? Degrees. I don't know. Can you go to the restroom? No. You can go. That doesn't mean you may go. All right. Okay. Shh, 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 shh. Example 5. Last example. Okay. From the top of an 108-foot lighthouse, the angle of depression is 27 feet. Okay, look at our triangle. This is our triangle here. Angles of depression are not inside the triangle, so where does the angle of depression have to be? Here or here? Right here. This is 27 feet, 27 degrees. And if that's 27 degrees, what does this one have to be? Find the horizontal distance. That's the horizontal distance right here. So we have an opposite, we have a adjacent. Opposite and adjacent is tangent. Tangent of 27 is equal to opposite 108 over x. X is on bottom. When x is on bottom, you flip them around and you divide. X is equal to 108 divided by tangent of 27. 108 divided by tangent of 27. X is equal to, we'll just say 212 feet. Well, it tells you to round to the nearest foot here. When it doesn't tell me where to round, I just default round to the nearest whole number. What? For me, I don't think there is an actual default.
Mr. Wright, can we finish the question?
1 second. All right, you guys have a test tomorrow.